Open almost any modern smartphone spec sheet, and you are bound to hit a massive, eye-catching number, the 200 megapixel camera. On paper, these components all sound identical, creating a paradox for anyone trying to figure out what they are actually buying. This diagram reveals the shared DNA of Samsung's ISOCELL lineup. The HP3, HPX, and HP0 share a unified geometry and exactly 200 megapixels. But this identical foundation fractures into three different identities: a technical baseline, a regional twin, and a flagship telephoto platform. Judging a modern phone camera entirely by its bare silicon physics and raw megapixel count has become a dangerous trap for consumers. The specs imply parity where none exists. Because these sensors start with the same physical footprint but produce entirely distinct results, we can no longer evaluate them using a single uniform metric. To understand why, we must transition down to the microscopic scale to see what the physical silicon is doing in all three sensors. This schematic shows the Tetra²pixel funnel artificially fusing 16 tiny pixels into one larger pixel, dropping resolution to 12.5 megapixels for light retention. Alongside it, the Super QPD architecture layers a microlens across 4 adjacent pixels for dense phase information. Yet, looking at this table of analytical boundaries reveals a deliberate gap. Samsung leaves crucial enthusiast evaluation metrics entirely blank in their global documentation. Quantum efficiency and specific read noise are stamped completely unspecified. These omissions underscore a critical limitation. The silicon is only the first of 5 distinct stages in the modern imaging chain. In this context, the bare sensor represents just 20% of the total pipeline. Zooming out from the bare silicon, we hit the next layer of the stack, the image signal processor, or ISP. This is the computational brain of the phone, and it strictly dictates what the physical sensor is allowed to do. This matrix highlights an implementation divergence between two identical sensors. The HPX fails because a restricted ISP bottlenecks the hardware, capping a highly capable 8K sensor to a 4K at 30 frames per second ceiling, resulting in grainy low light performance. A theoretical maximum of 200 megapixels is irrelevant if the phone's computational brain lacks the processing power to handle the data. To see the other extreme, we zoom out to the absolute macro level. We need to look at what happens when this 200 megapixel baseline is surrounded by a massive, uncompromised hardware stack, like the ultra-premium HP0 platform. In this exploded diagram, the system drives light through an 85mm APO lens, using heavy-duty optical image stabilization actuators. Below the silicon sits a dedicated VS1 Plus raw domain chip. Pushing multifocal 4K video at 120 frames per second generates an extreme 54.8 degrees Celsius thermal load. The HP0 is an aggressive optical and computational machine. The 200 megapixel silicon is merely the foundation it sits upon. This diagram visualizes the modern diagnostic asymmetry. Final image quality is the sum of the sensor, the lens aperture, the ISP, the stabilization mechanics, and the thermal budget. Comparing the raw physics of bare sensors is a necessary first step, but it is entirely insufficient on its own. This decision matrix maps the buying landscape based on specific priorities. For the cleanest technical baseline, choose the HP3, but for extreme telephoto reach and pro video, choose the HP0 implementation, accepting the immense thermal demands. Stop buying smartphones based on isolated spec sheets. In modern mobile photography, the surrounding pipeline is the true product.